Kirsten. Welcome to Real World Science. Light is a very important part of our everyday lives, and it is the focus of this Real World Science program. What is light? When you think about light, what comes to mind? Light bulbs? Fire? The sun? Well, those are all sources of light, but do you know what light is? Simply put, light is energy that you can see. On a sunny day, not only can you see light, but you can feel the heat it gives off too. Want to know why? Come on, I'll show you. You already know that light is energy, so how does that energy get from the light source to you? Well, light travels in the form of a wave. The wave is actually a disturbance created by the transfer of energy. We can demonstrate that. If you look at the surface of this lake, the water appears fairly smooth. Watch what happens when a stone hits the water. When the energy from the stone is transferred to the water, waves are formed. If you could see a light wave, it would look something like this. Notice how it goes up and down. This type of wave is called a transverse wave. Light waves are unique because they don't require a medium in order to travel. A medium is any solid like the ground, liquid like water, or a gas like air. That's why, even though space is a vacuum with no air, you can see light from stars that are thousands of miles away. Properties of light. Let's examine some properties of light waves by looking at a graphic of a wave. Waves go up and down with high points called crests and low points called troughs. The first property we are going to discuss is amplitude. We can measure amplitude by measuring the height of a wave, the distance between the center of the wave, and the crest or the trough. Another property of a light wave is wavelength. Wavelength is determined by measuring the distance between two high points or two low points on a wave. Frequency is another property of light waves. This is a measurement of the number of waves that pass a certain point in a given time period. Frequency is a very important property of light waves because it is one of the properties that set light waves apart from the other kinds of waves. The frequency of a light wave determines where it appears on something called the electromagnetic spectrum. Let me explain further. Light waves are a special kind of waves called electromagnetic waves. Electromagnetic waves transfer electric and magnetic energy, and those waves are part of something called the electromagnetic spectrum. That's the name for the range of electromagnetic waves in order of frequency. All electromagnetic waves travel at the same speed, but have different wavelengths and frequencies. The electromagnetic spectrum is made up of radio waves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. As you can see, light waves fall somewhere in the middle of the spectrum. The fact that you can see light waves is very important. That's one way they are different from all the other electromagnetic waves. They are visible. Before we go any further, let's take a moment to review what you have learned so far. You know that light is actually a visible form of energy, and that light travels in waves called transverse waves. Those waves have special properties that include wavelength, amplitude, and frequency. You also learn that light waves don't require a medium in order to travel. And you learn that light is part of the electromagnetic spectrum. What makes light waves special? As you have probably guessed, there are lots of characteristics that make light waves special. The frequency and wavelength of light waves give light some unique properties. We said that light travels in waves, but if you look at those waves really closely, you'll notice that they are very short and travel very fast. And because of the high frequency and short wavelength, light waves act a lot like a moving particle. Each of those little packets of moving energy is called a photon. Light waves are also sometimes called rays or beams. Light rays travel in a straight line. A light ray will keep going straight until it hits something. When a light ray encounters an object, it can do three things. It can be transmitted, which means that it passes through the object. It can be absorbed, causing the light energy to change into heat. Or it can be reflected, meaning the light will bounce off the object. In most cases, a combination of all three will happen. When an object reflects all the light or absorbs all the light that strikes it, we say that the object is opaque. If the object transmits light, we can say it is transparent. In this case, you can see how both light passes through an object and is reflected at the same time. Other objects only allow sunlight to pass through them. Notice how you can see the outline of her face through this scarf, but she's not completely visible. Objects like this scarf that lets sunlight through, but blocks sunlight, are called translucent. Let's review some of the new things you learned. Now you know that light waves can act like moving particles and are sometimes called rays or beams, and that light rays always travel straight until they hit something. When light rays hit an object, three things can happen. They can be transmitted, absorbed, or reflected. Usually, a combination of all three things happen. Now you know that objects that do not allow light to pass through are opaque. Objects like glass that allow light to pass through are transparent. And objects that allow only sunlight to pass through are translucent. Reflection and refraction. The reason you are able to see anything is because light reflects off objects. The way that light will reflect off an object depends on the object's surface. Let's take a look at what happens when light rays hit a rough surface. The light scatters in different directions. But when light hits a smooth surface, like this mirror, all of the rays go in one direction. The light bouncing off hits the mirror, then bounces right back in one direction. A property of light that we have not discussed yet is refraction, the bending of light rays as they enter a new medium. There's a riddle that goes along with this one, and you can try it with your friends. Can you get this pencil to bend using only water? Sure, anyone can. Just watch. Ta-da! The pencil is bent, and all it took was placing the pencil in a glass of water. But did the pencil really bend? Well, no. But it appears that way when it is partially submerged in the water. Why? As light passes from the air to water, it experiences a change in speed and the light bends. The same happens as the light goes back into the air. So So the light rays, not the pencil, are actually bending, and that changes our perception, how we see the pencil. If you have ever gone diving for objects at the bottom of a pool, you have seen this principle in action. When you look at the bottom of a pool, it appears as though it is here, right? But when you reach down, it is not where you thought it was at all. It's further back. That's because, just like with the pencil, the light rays have bent as they enter a new medium. Scientists use the principles of light bending for all kinds of things that make our life easier in the real world. Things like magnifying glasses, reading glasses, and even cameras. What is color? The science of light isn't just for scientists. Everyone uses it, even artists. We talked about how light is part of the electromagnetic spectrum, and that light is the visible part of the spectrum. One of the most interesting aspects of visible light is color, and artists know more than a thing or two about color. If you've ever seen a rainbow, you've probably seen all of the colors of light. They are red, orange, yellow, green, blue, indigo, and violet. Lots of people remember those colors using an acronym, which is an easy way of remembering the colors using the first letter of each color, Roy G. Biv. All of those colors make up the color spectrum, and each color represents a small change in frequency within visible light. When you see what we call white light, what you are actually seeing is all of the colors of the rainbow mixed together. A prism is a uniquely shaped object that can separate white light into individual colors. Artists use 3 primary color pigments, which are all opaque, to create all of the other colors. The primary colors of pigments are magenta, cyan, and yellow. Put together equal amounts of all 3 colors and you get black. By mixing together varying amounts of those colors, they can create orange, purple, and just about anything else you can imagine. Light comes in 3 primary colors too: red, blue, and green. And just like with those pigments, those colors can be mixed to create any color. Put all 3 of those colors together in equal amounts, and you have white light. So, we know what colors are. They are different frequencies of visible light. But how exactly do we see them? Well, it goes back to the properties of reflection and absorption. When you look at an apple, you see red because red light reflects off of the object. All of the other colors are absorbed by the apple. When light hits something white, all the colors are reflected. When light hits something black, all the colors are absorbed. So the color you see when you look at an object depends on which colors are reflected and which are absorbed. Believe it or not, reflection and absorption often determine your wardrobe. For instance, if it's really sunny and hot outside, you definitely wouldn't wear black clothing. That's because all the light would be absorbed by your clothes and would be turned into heat. Put on something white that reflects light, however, and you're likely to be cool as a cucumber. As you can see, light makes it possible for us to do ordinary things like reading a book at night, watching television, or coordinating our wardrobe. And it makes it possible for us to do extraordinary things like creating spectacular fireworks shows. Light, it makes everything brighter in the real world.